This is the question number 39 of GATE 2012 Metallurgical Engineering. Match the phases of steel in group 1 with the crystal structure in group 2. In the group 1, different phases of steels are given. P. Martensite, Q. Cementite, R. Austenite, S. Ferrite. And in the group 2, different crystal structures are given. 1. BCC, 2. FCC, 3. BCT, 4. Orthorhombic. So we have to match the phases of steel with their corresponding crystal structure. So 4 different options are given. So now let us solve this question. So now let us look each phases one by one. So first one is the martensite. So martensite is a phase which consists of supersaturated carbon in iron, which is basically formed when we rapidly quench the austenite below the MS temperature. So austenite phase, if you see the iron carbon phase diagram, austenite phase, it is a non-magnetic allotropes of iron or a solid solution of iron with an alloying elements like carbon, or there may be some different alloying elements. This austenite has a crystal structure of phase center cubic. So this austenite is FCC. So if we suddenly quench this FCC austenite structure below MS temperature, so because of the bend distortion, it will contract in the C direction, and it will end up with the BCT structure. In case of others martensite, like nickel based martensite, so they have BCC structure. But in case of steel based martensite, as the carbon atoms are present at the octahedral voids, which is located at the edge center, so it hinders the contraction along the C directions. So that's why in steel based system the martensite structure is BCT, that is body centered tetragonal. So in the group 1, this P will go with the this 3. So this is and now let us see the second option, that is cementite. So cementite, as we know, it is a compound of iron with carbon. So it is denoted as Fe3C. So this cementite has a crystal structure of orthorhombic. So as you can see the structure here, so in this orthorhombic unit cell of cementite, there is 4 carbon atoms are there, and total 12 iron atoms are there. So 4 carbon atoms are there and 12 iron atoms are there. So cementite has a orthorhombic structure. So this Q will go with option 4 in the group 2. And now austenite is FCC structure, which we have already mentioned earlier. Here the color of the atoms are different just to describe the different locations of the atom, not the type of the atoms. So the R in the side of group 1, that this will go with the 2 in the group 2. And ferrite has BCC structure. So where 8 atoms located at the corners of a cube, and 1 atom located at the body centered position. So S will go with the 1 in the group 2. The correct answer will be P with 3, Q with 4, R with 2, and S with 1. So the correct answer will be option C.